300 grams of water at 25 degrees Celsius is added to 100 grams of ice at 0 degrees Celsius. Find the final temperature of the mixture. So let's find it out. So there is a hot body, means the water, and there is a cold body, means the ice. This is the water part and this is the ice. So the mass of the water is given by 300 gram and the mass of the cold body, means the ice, is given by 100 grams, and the temperature of the water is given by, the temperature of water is 25 degrees Celsius and the temperature of ice is 0 degrees Celsius. So now look at this, that from principle of calorimetry, that from a hot body, the temperature always flow from the hot body to the cold body, right? From the hot body to cold body, the temperature will flow. So now look, from this side to this side, the temperature will flow. After flow of the temperature, the temperature of the mixture is theta degree Celsius. So, and there is a phenomenon, that while the ice is absorbing heat from the water, at first the water of 0 degrees Celsius. So in this process, while this process is happening, we need latent heat of fusion for ice. So we need latent heat of fusion to melt the ice. So what is the latent heat of fusion? It is amount of the heat that is required to convert the phase from solid to liquid. So in this case, the latent heat of fusion we have to find out, and let's find out that what is the temperature that can be passed from the water to the ice body. So the latent heat of fusion will be given by, for 100 gram of ice, latent heat of fusion required for 100 gram of ice, it is given by Qi. I'm denoting as Qi. It is given by m, the mass of the ice, into the specific latent heat for fusion. M is given by, for ice is given by 100 gram. It's given that 100 gram of ice into the latent heat of fusion for ice is given by 80 calorie per gram. So gram will be cancelled and this will be 8000 calorie, means 8000 calorie of heat is required to change the phase from solid to liquid in case of ice. Now let's see that the heat released by the water. Now temperature is given 25 degrees Celsius and the mass is given 300 grams. So this amount of water can release heat. Qi released is equals to the total, let's say the total heat can be released by the body is given by mCT. So it will be, m is given by 300, the mass of water body is 300. So what is the specific heat capacity for water? It is 1 calorie per gram degree Celsius into the temperature is given 25 degrees Celsius. Degree will be cancelled, gram, and this is also gram will be cancelled, and this will be 25 into 3. How much is this? 775 calorie. So now you have to see that this is the amount of heat that the maximum amount of heat that can be released by released by water body, and this is the heat required to change the phase of 100 gram of ice to water, of course at 0 degree Celsius. Okay, so as you can observe that there is insufficient amount of heat that can be released from the water body to make the ice melt. So what will happen? So this amount of heat will melt. Now you can, of course, if in competitive exam you can say that, so the answer will be 0 degree Celsius, because all the heat from the water body is absorbed by the ice and converted into water, so it will be 0 degree Celsius, and is 0 degree Celsius and some amount of, like, okay, I'm explaining. So like, say this amount of water, sorry, like you have this amount of water at 25 degrees Celsius, and there is a and there is a iceberg, okay, at 0 degrees Celsius. Now you pour all the water into the ice. All the water is required to melt the ice. All the heat is required to melt the ice, so the ice will melt and convert it into water, but few amount of ice will still remain. This is remaining. So in the solution, this will be 0 degree Celsius, and the ice that is left is also 0 degree Celsius. So we got the temperature of the solution or the mixture is 0 degree Celsius. So the answer will be 0 degree Celsius. So now to explain what will happen, that you can clearly see that this amount of heat is available and this amount of heat is required to make all the ice converted into water. So not all the ice will be converted into water. Some amount of ice will remain. Of course, some amount of ice will remain only. Now we can also calculate the amount of ice that will be remain. How to calculate that also we will discuss that. Find out that how much amount, what is the amount of ice that will melt. That is, for 100 gram of ice we need 8000 calorie heat can convert 100 gram of ice into water. So one will convert 100 by 8000 and 7500 will convert this gram of ice, and this will be nearly about, let's calculate this, this will be nearly 93.75 grams. So the remaining ice will be 100 minus 93.75 gram. It is like 6.25, right? This amount of ice will not convert into water. Thank you.